which of the following is an example of runtime polymorphism in Java? Method overloading, method overriding, using the final keyword, using the static keyword. So its correct answer is method overriding. So in the explanation, runtime polymorphism is achieved through method overriding, where the method that is called is determined at actually runtime. Other options are incorrect because method overloading is an example of compile time polymorphism, and final and static keywords not relatable to any runtime polymorphism. Our next question is, which of the following statements is true about abstract classes in Java? Option A, an abstract class can have both abstract and concrete methods. Option B, an abstract class cannot have a constructor. Option C, an abstract class must be declared as final. Option D, an abstract class can be instantiated. So here the correct answer is option A, which is abstract class can contain both abstract methods without a body and concrete methods, which means with body. Other options are incorrect because abstract class can have constructors. An abstract class cannot be declared as final because it must be inherited. So once you declare a class as abstract, in order to create its object, you have to use inheritance. An abstract class cannot be instantiated directly. So to instantiate it, obviously you have to create a subclass for it. Our next question is, which of the following allows a class to be inherited but not instantiated? Final class, abstract class, interface, static class. So here the correct answer is abstract class. An abstract class can be inherited but not instantiated directly. Other options are incorrect because a final class cannot be inherited. An interface is not a class first of all, and it cannot be instantiated. Static class is not a concept in Java for outer class. Our next question is, what is the result of attempting to inherit from a final class in Java? The subclass will inherit all the methods from the final class. The subclass will override methods from the final class. A compilation error will occur. The subclass will inherit fields but not methods. So here the correct answer is a compilation error will occur. As you can see in the explanation, a final class cannot be inherited, so attempting to do so will actually cause a compilation error. Other options are incorrect because methods and fields cannot be inherited from a final class. So once a class is defined as final, it cannot be inherited further. Our next question is, which of the following best describes method overloading in Java? Defining two or more methods with the same name and different parameters listed in the same class. Defining two or more methods with the same name and same parameter listed in different class. Defining a method in a subclass that overrides a method in the parent class. Defining a method in an interface and implementing it in a class. So the correct answer here is option A, because method overloading happens when the multiple methods with the same name but different parameters are defined in the same class. Other options are incorrect because methods with the same name and parameters list in different classes are actually unrelated. Overriding a method is related to polymorphism, not overloading. Our next question is, which of the following is not true about interfaces in Java? An interface can have default methods. An interface can contain constructors, and a class can implement multiple interfaces. An interface can extend another interface. So here the correct answer is option B. As you can see, interfaces cannot have constructors. Other options are incorrect because interface can have default methods also. A class can implement multiple interfaces allowing multiple inheritance, and an interface can extend another interface. So here option B is not related to interface. Our next question is, which of the following keyword is used to prevent method overriding in Java? Final, static, abstract, or synchronized? So here the correct answer is final. So the final keyword is used to prevent a method from being overridden in subclass. And other options are incorrect because static methods cannot be overridden, but it's not related to preventing overriding. Abstract is used to declare abstract methods. not to prevent overriding, and synchronized is used for thread safety and it is not related to method overriding. Our next question is, which is the output when a method with the same name is defined in both the parent class and subclass and the method is called on the subclass object? Option A, method in the parent class is executed. Option B, the method in the subclass is executed. Option C, both Option C, both methods are executed. Option D, compilation error. So here the correct answer will be option B because it is actually an overriding scenario. As you can see in the explanation, when a method is overridden in a subclass, the method in the subclass is actually executed even when the method is called on a subclass object. Other options are incorrect because the parent class method is not executed actually and only one method is executed, not both. Our next question is, which of the following statements is true about multiple inheritance? Option A, Java supports multiple inheritance through classes. Option B, Java does not support multiple inheritance at all. Option C, Java supports multiple inheritance through interfaces. And option D, Java supports multiple inheritance through abstract classes. So here the correct answer is option C because Java does not support multiple inheritance through classes but it does through interfaces. Other options are incorrect because Java does not support multiple inheritance directly through classes and abstract classes do not support multiple inheritance like interfaces. Next question is, which of the following best describes an abstract method in Java? A method with a body that can be overridden, a method that is defined in a subclass only, a method without a body that must be implemented by subclass, and a method that cannot be overridden. So here the correct answer is option C. As you can see in the explanation that abstract methods do not have a body and must be implemented by subclasses. Other options are incorrect because a method with a body can be overridden, but it is not an abstract method. Abstract methods are typically defined in abstract classes, not subclasses, and abstract methods are meant to be overridden. So if you are defining any abstract method, then you must have to override it. Our next question is, what does the instance of keyword do in Java? Option A, it checks if an object is an instance of a specific class or subclass. Option B, it creates an instance of a class. Option C, it checks if a class is abstract. Option D, it creates a copy of an instance. So here the correct answer is option A. As you can see, the instance keyword checks if an object is an instance of a specific class or subclass or not. Other options are incorrect because the new keyword is used to create instances. The abstract keyword is checks if a class is abstract, and cloning creates a copy, not instance of. Our next question is, which of the following statements is true about constructors in Java? Constructors can be inherited, constructor cannot be overridden, a class can have only one constructor, constructor can return a value. So here the correct answer is option B because constructor cannot be overridden because they are not inherited by subclasses. Other options are incorrect because constructors are not inherited, so they cannot be overridden. A class can have multiple constructors which uses the concept of constructor overloading, and constructor do not return a value. So here the correct answer will be option B. Our next question is, which of the following is true about a final method in Java? Option A, it can be overridden in any subclasses. Option B, it cannot be inherited by subclasses. Option C, it cannot be overridden in any subclasses. Option D, it must be abstract. So here the correct answer is option C. As you can see, a final method cannot be overridden by subclasses, ensuring that the method's behavior remains consistent across all the instances. Other options are incorrect because final methods can be inherited but cannot be overridden. Final methods cannot be abstract. Our next question is, which of the following is not an example of encapsulation? using private access modifiers for class variables, providing a public getter and setter methods, restricting, restricting access to internal class methods, using the extends keyword to inherit a class. So here the correct answer is option D. As you can see in the explanation, the extends keyword is related to inheritance and it is not related to encapsulation. Private access modifiers, getters and setters are common ways to achieve encapsulation, and restricting access to internal methods, it is also a part of encapsulation. Our next question is, what is the main purpose of polymorphism in Java? Option A, to allow multiple classes to inherit from a single class. Option B, to allow a single method to behave differently based on the object it is acting upon. And option C, to create multiple objects from a single class. And option D, to enforce data hiding within a class. So here the correct answer is option B. As you can see, polymorphism allows a single method or operator to take on different forms, which enables different behavior based on the object. Other options are incorrect because inheritance is not polymorphism, which allows multiple classes to inherit from a single class. Polymorphism is not related to object creation or data hiding. Our next question is, what happens if a class in Java is declared abstract but contains no abstract methods? Option A, the class will cause a compile time error. Option B, the class can be instantiated like any other class. Option C, the class cannot be instantiated but can be extended by other classes. Option D, the class must contain at least one abstract method to be declared abstract. So here the correct answer will be option C. As you can see, an abstract class in Java cannot be instantiated regardless of whether it contains abstract methods. It can still be extended by other classes. Other options are incorrect because declaring a class as abstract without abstract methods does not cause a compile time error. An abstract class cannot be instantiated, and there is no requirement that an abstract class must contain at least one abstract method. Our next question is, which of the following statements about interfaces in Java is not true? An interface can contain method signatures without implementation. A class can implement multiple interfaces. An interface can contain fields that are implicitly final and static. A class can inherit the implementations of method from an interface. So here the correct answer is option D. As you can see, interfaces do not contain method implementations. They only contain method signatures. So a class cannot inherit method implementation from an interface. And other options are incorrect because interface can contain method signatures without implementations. A class can implement multiple interfaces, which enables a form of multiple inheritance, and fields in an interface are implicitly final and static. So now let's go to our next question, which is, what will happen if a class does not implement all the methods of an interface it implements? The class will compile successfully. The class must be declared as abstract. The class can still be instantiated. The class will generate a runtime error. So here the correct answer is option B. As you can see, if a class does not implement all the methods of an interface, it must be declared as abstract. Otherwise, it will result in a compile time error. Other options are incorrect because the class will not compile successfully unless it is declared as abstract. The class cannot be instantiated if it is abstract and does not implement all the methods of an interface. The issue is detected at compile time and not runtime. Our next question is, which of the following best explains the concept of loose coupling in Java? Loose coupling is achieved by making all class members as public. Loose coupling is achieved by ensuring that classes interact only through interfaces or abstract classes. Loose coupling is achieved by making classes dependent on each other's internal implementations. Or loose coupling is irrelevant to object-oriented programming. So here the correct answer is option B. As you can see, loose coupling is a design principle that aims to reduce dependencies between classes by having them interact through interfaces or abstract classes, which makes the system more flexible and easier to maintain. And other options are incorrect because making all classes public increases coupling, not reduces it. Classes dependent on each other's internal implementations are tightly coupled, not loosely coupled. Loose coupling is highly relevant to object-oriented programming as it promotes flexibility and reusability. Our next question is, what will be the output if a method in a subclass has the same name and parameters as a method in its superclass but has a different return type? The program will compile and run successfully. The program will compile but throw a runtime exception. The program will not compile due to a method signature conflict. The program will override the superclass method with the subclass method. So here the correct answer is option C. As you can see, in Java, method overriding requires that the method in the subclass has the same name, parameters and return type as the method in the superclass. A different return type will cause a compile time error. Other options are incorrect because the program will not compile, so it cannot run successfully. No runtime exception will occur because the program will fail to compile. The subclass method cannot override the superclass method if the return type differs.